Looks like I set a due date for next Monday for the Chapter 3 quiz. Obviously, we're not halfway through the thing, so I'm going to postpone that a week. Doesn't mean you can't read ahead and do the quiz anyways, right? But not going to make it mandatory. So I've demonstrated this before, the ability to format your output so that you can specify how wide an element will be. This is not really the best example at all. I don't understand what they're trying to prove here, because to me that output looks the same as that output. Maybe it was supposed to be in a monospace font, Courier. Nope, they just botched that example. Here's what it's supposed to look like when it prints out. There we go. And even if this was the same font, it would not look the same according to the print statement. The problem being is that some of these, are 1 wide. Some of these are 2 wide. So obviously they don't line up. By doing this, percent, even if we left that off, I'm going to do that temporarily. If we left that off, here's what it would look like. What we really ought to do is just type this code in and play with it. But what %3D means is reserve 3 spaces for an integer value, D meaning integer. Not how sure they came up with D meaning integer, but that dates back to the 70s. So, and then 12D means save 12 spots for the next one. They've totally botched this example. We'd better just type it in and play with it ourselves, because their slide here is just totally wrong. I'm tired of trying to make it look right. Let's go ahead and launch idle if you want to play along. And we're going to write a little loop that's going to print like something to the power of, 10 or 2 and something to the power of 4. So we need a counter. I believe we're on I. We're on H. Erase that I. There we go. So we need a counter for I in range. I want it to go from 5 to 15. So since I want it to stop at 15, I better make that 16. Make that a colon. I'm going to put a comment that counts from 5 to 15. Just because it always hangs people up that you have to make this one larger or one beyond where you want it to stop. Okay, so I'm going to print I, comma, I to the power of 2, comma, and I to the power of 4, for whatever purposes. All right, it printed some output, and it's not really very nicely lined up, right? It's not in what the slide called tabular format. Where did it call it that? I swear it did. formatting text for text output. Many data processing applications require output that has tabular format. In other words, like you're hitting tab on a typewriter keyboard, but we can do more sophisticated stuff than just that. So sometimes this field is only 1 wide, and sometimes it's 2 wide. And if we let it go far enough, it would become 3 wide. But let's make a spot for it that's just 1 wide. Excuse me, 2 wide, right? Because it can go up to 2 characters. We'd like for it to have 2 spaces reserved the whole time. And this one goes from 2 up to 3. So we're going to need one that's 2 wide, we're going to need one that's 3 wide, and we're going to need one that's 5 wide. So we're going to change this to a formatted print. Firstly, since I know we need it, I'm going to put a parentheses at the end. And then I'm going to put a parentheses at the beginning, followed by the quote. And I said percent, it needed to be 2 wide, and then 3 wide, and then 5 wide. End quote. Whoopsie, go back. End quote, percent sign. And so the percent sign means that we have some placeholders to fill, and then the thing between the parentheses are the values that are supposed to fill in the placeholders. Much better, right? All nicely lined up. These numbers are right justified. If you like them being left justified, you can make them left justified by putting a minus sign after the percent. That means left justify. Line them up on the left margin. Like that. Now they're left justified. I kind of think they looked better right justified. So I'm probably going to take the minus signs off. So what is this? This is an example of tabular, which I would say is column, output. %2D means reserve 2 spaces for an int. %5D, right, means the same. Not all of our data is int, and you've seen me use percent before. Usually I was doing it to control the number of decimal places something could have. So we're going to do another example like that. So for I in range, (5,16), and I don't really know what this is going to look like, so we'll find out. Again, that's 5 through 15. We're going to print I, comma, and 10 divided by I. I'm just making up these values to try to come up with something that'll be kind of interesting when we see the output. All right, and there we go. That looks kind of lame. So again, we're going to want to format the first one to be 2 characters wide, to have 2 spaces reserved for it. But then we also need to pick how wide we want these to be. I think about 1, 2, 3, 4, 5, 6 would be wide enough. So I'm going to modify this one similarly to the other one. Now floating point numbers, the ones with the decimals, have to be formatted with %F, not %D. So again, I'm going to put a closing parentheses there. And at the opening, I'm going to put a parentheses quote, %2D space %5F. End quote, followed by a % sign. All right, that actually turned out pretty nice. I thought we were going to have to make another change. You can also specify the number of decimal points you want, which in this case might be a good idea. Change this from 10 divided by I to, I don't know, 50 divided by I. All right, we do see something that could be improved, right? I think I would kind of like it if the decimal points were lined up. I think that would make it easier to read. And right now, they're not lined up. I'm kind of surprised by what I'm seeing, actually, because this one is way more than 5 wide. What the %5 seems to be indicating is purely, doesn't seem to be anything at all. Why did it cough up that? Well, here's what we're going to try next.
5 values before the decimal?
Is that what it's trying to do? Well, let's see. We're going to do %.2f just to see 2 decimal places. That's looking better, but the decimal points are not lined up. So I'm going to do %5.2f to get it to totally occupy 5 spaces, reserving 2 for the decimal point. And now it looks like I wanted. I'm really not clear on what it was doing there that gave me that. But if you specify the number of decimals, that's great. And then you can specify how many spaces total you want it to fill. And you get total control over the way you want it to look. Like that. And of course, we can always make things prettier by adding spaces or whatever. You can also just separate numbers with tabs. I'm going to duplicate that first one. We're not going to like the results so much. For I in range 5, 16, parentheses, colon, print. I'm not going to even give this an example. Forget this one. Oh, yeah, I guess I will. Print I, comma, followed by a tab, which is a quote, \t, end quote, comma, I star star 2, comma, quote, \t, quote, comma, I star star 4. And that's just going to separate things by tabs. And it kind of looks good. Sometimes it won't. Once this data becomes too large to fit in one tab, then it's going to become totally off, right? Because some of it's going to be way over here. I'm not going to come up with an example of that. This gives you kind of a very loose control over it, and sometimes it works, and if you feel like doing it, great, but you may revert back to doing it in a more controlled formatting style. So, the % marks placeholders. D for ints, whole numbers. F for floats. S for string. If you follow % with a number, that indicates how many columns on the screen you want it to occupy. If it's floating point, you can specify how many decimal places. So %.2f means show 2 decimal places. %10.2f means show 2 decimal places, occupying 10 total, including the decimal point. So this would contain numbers, that's 2 and that's 3. 10 minus 3 is 7. so we could have 7 numbers before the decimal point and then 2 following it. If the data is too large to fit in the space allocated, too bad, your spacing becomes off. Just to demonstrate that, rather than type it all in again because it's kind of tedious to type it all in, grab this guy, copy it, scroll back down, paste it, but we're going to make the columns not wide enough. Let's say I forgot that that one was going to be 2 wide, or 3 wide, and I said only 2 there. Then when I run it, it doesn't work the way we want. Actually, that output looks okay, but it's really not. Can't explain why it's not, because it actually looks pretty good. But you can, what if we changed them to 1Ds? And now it's kind of back to looking like it did at the very beginning, right? Because when it got to filling 2 places, it couldn't squish 2 to fit in a space of 1, so too bad, right? It couldn't format it correctly. And then similarly, that one, when it was 2 or 3, could not fit adequately, so the spacing got all thrown off. So this has to be at least as large as the data you're trying to print, else it's kind of useless. So they're calling the number after the percent sign the field width. That's a nice term. And they're calling the number after the decimal the precision. And the precision is optional. You want to print something out to dollars and cents? Very commonly, you will use %.2f. I don't know why they put the 0 there. That's not necessary. You would leave that off. That way you get, 2 places after the decimal point, because it looks kind of lame to show something with only 1 place after the decimal point. Note that they want the dollar sign to appear right next to the number, so they didn't use comma. If they'd used comma, like that, then we would see that. That's not terrible, but it'd look better to use a plus sign so that the space would be removed. And since they used a plus sign, since we're doing concatenation, we had to turn this floating point number, this number, into a string. So selection statements, those are your if statements. And we have several comparison operators. We have equal, equal. We have not equal. And then our good old standbys from elementary school: less than, greater than, less than, equal to, greater than or equal to. This is the only one that's kind of different. Well, you might think that you could use a single equal to do a comparison, but you can't. Just accept that. And in grade school, you might have written not equal to as that. But in this one, it's not equal to. And when I'm writing it out, I'm probably going to say not equal, rather than remembering to say exclamation point equal. If you hear me say not equal, type exclamation point equal. So we have if statements, and we also have if-else statements. And then we have if-elif else statements. So we essentially have 3 kinds. So I'm just going to place some number in here that's supposed to be the temperature, right? Temp is equal to 65. And then I'm going to write an if statement. If temperature greater than 212, colon, print boiling. Is it going to print anything? No, it's not. Not that you can see it down there. Maybe I can hide the taskbar. mistake, but I'm going to try it. It didn't print anything. Why? Because temperature is not greater than 212. So we could put an else in there. Else colon, print, parentheses, quote, not boiling, end quote, in parentheses. And it printed not boiling. However, if we're talking about water, which apparently we are since we used boiling and not boiling as our phrases, there's a third state that's of interest to us, right? Freezing is a third state. And an if-else kind of only offers us two choices. We can make do by doing it like this. And for a moment I would suggest not typing this because I'm going to revise it. I could do this. Else, if temperature is less than 32, colon, print freezing, else, colon, print liquid. Right, something like that. I could do that. That's kind of clumsy, though. There's a cleaner way of doing it. And that cleaner way is to do this. elif, colon, elif temp less than 32, colon, print, parentheses, quote, freezing, end quote, in parentheses, else, colon, print liquid. If you've used other languages, you probably used else if. I like the words else if. They don't look like they're a syntax error, but when you run it, it comes up being a syntax error. So in this particular languages, we use elif to mean else if. So use if to allow one choice or nothing, right? Do something or do nothing. Use if else to allow two choices. Use if elif else to allow three or more choices. Why do I say or more? Because we could put as many conditions as we wanted to here, right? In this particular case, we're only checking three states. But, you know, if there was a fourth state that I want to add, you know, the temperature of plasma or something like that, right? I could do that. Okay, this is going to be dumb, but I'm going to go ahead and add one more elif just to give you an example. So under the first elif, print freezing, I'm going to do a second elif. Elif temperature is exactly equal to 98.6, colon. I'm going to print, parentheses, quote, body temperature. That's just to have a fourth choice. That's the only reason I put that in there. And I got it wrong because you have to use two equal signs. Else temp equals 98.6, print body temperature. All right, and so it didn't print body temperature, but we could make it do so if we went and edited, right, our input there. Okay, so you can chain as many elifs as you want, as you need to. You can also nest your if statements. Are we a recent grad? Recent grad equals, quote, y, end quote. Nope, single equal. I can't believe I'm messing these up. And then, what's the other term we could do if we're a recent grad and do we have a job? Employed equals, quote, yes, end quote. So we could set up an if statement. If recent grad equals, quote, y, end quote, equals, quote, y, end quote, colon. And then in here, if employed equals, quote, y, end quote, colon, print you qualify for the discount. Now I'm going to backspace one, else colon, print quote, good luck getting a job. Kind of a rude program, but okay. And then lastly, if we're not a recent grad, say, go back to school. Print, parentheses, quote, go back to school. Now really we should be asking, right, to test all three of these states. But whenever we make a program that asks input, every time we run it, we have to type in something. If we wanted to, we could make these, input statements. So what does this do? Well, if the recent grad is Y, we go ahead and get in here, because this is the gatekeeper to that if block. And once we're in there, we check to see if they're employed. If both of those cases are true, we print, you qualify for the discount. Else, we print, good luck getting a job. And if this one wasn't true in the first place, we just tell them to go back to school. We could simplify this logic, perhaps. Because if you have this and this, both of those have to be true. You can think of that as if recent grad and employed, right? If both of those cases are true, we want to do something. So if recent grad, let's push this up so everybody can see it. If recent grad equals, quote, Y, end quote, and employed equals, quote, Y, end quote, print, discount available, end quote, in parentheses, next line, else colon, print, no discount, end quote, in parentheses. So this is known as nested if. Nested just means something inside of something, and you can have if statements that are nested inside ifs. You can have ifs nested inside whiles. You can have whiles nested inside of ifs. You can have fors nested inside fors. Right? You can nest any kind of structure in kind of any other structure. And so when I run it, it's going to print you qualify for the discount, and it's going to say discount available just because I set both of those things equal to Y. Some people like to do this. What if it was lowercase? What if we want to support lowercase? If recent grad equals, quote, Y, or recent grad equals, quote, lowercase y. I'm not going to make that same change everywhere, especially here. We could, but its statement would wind up being this long, and we'd have to put parentheses in it to accomplish it, and I'm not going to bother. So we have two keywords that are of import there. We have and we have or. They mean about the same thing. I mean, not the same thing. They mean what they mean in English, right? What if you want to go out and eat? Somebody invites you out to eat. Do you have money? And are you hungry? If neither one of those is true, you're probably not going to go out and eat unless you're just going to hang with them. Or you're going to mooch off them, right? So, and. Both cases have to be true. You have money and you're hungry. What if you're sick or you're tired? You want to decide whether you stay home. Sick or tired. Either one of those is true. And means both of those have to be true. So let's make a few notes here. Enough that I might open up a double quote here. A triple quote, excuse me. And both conditions, both sides must be true. Or means one condition or the other must be true. Also both, if both are true, then it works. You can construct what's known as a truth table. Why don't I just Google this up? Better make us all type it. Truth table for and. All right, if we read this, then what they're using here is this up arrow to mean and, which we certainly don't do in our programming. This is like discrete math and Boolean algebra. But what it's showing is that if you have two things separated by an and, they both have to be true. Like if P means I'm hungry and Q means I have money, then the only time the output is true is when I'm hungry and I have money. And then you have the or statement. They're using down arrow to indicate or. I don't care if you remember that. I'm not going to. I am sick or I am tired. The only case where I am not going to stay home is if I'm neither sick nor I am tired. If both conditions are false, the output is false. Otherwise, it's true, right? I'm not sick, but I am tired. I'm going to stay home. I must have a really nice boss. I'm sick, but I'm not tired. Well, that's kind of a weird state, but I better stay home. I'm sick and tired. Okay, I have two reasons to stay home. Here's a longer one, and if you're an engineer, electrical engineer, you probably you know more about this stuff than I do. When you're an electrical engineer doing logic gates, there's a lot more than just and or. There's something called NOR, which means not or. There's something called NAND, which means not and. And then there's exclusive or and exclusive and. But this is just showing the same thing. If we ignore the fancier columns, 0 meaning false and 1 meaning true. I'm not hungry, but I have money. Well, I'm going to stay home. I am hungry, but I have no money. I'm going to stay home. False. I am hungry. I do have money. I'm going to go out to eat. Right? Two truths make a true when we're talking about and. If you're sick or tired, the only time that you're not going to stay home from work is when you're neither sick nor tired. Now, all NAND means is you take the output of and then flip it. Right? You see that the only time that you go out to eat is when you have both money and you're hungry. Well, NAND just flips that output, right? We're not going to mess with that. NOR means flipping the output of OR. And when I say flip, I mean take a false and turn it into a true, or take a true and turn it into false. In electrical engineering, it's signal going down the wire, right? You have two wires leading into what's known as the gate, and based on whether it's an and or an or, controls whether there's any current going out of it. And an exclusive, they don't even have exclusive. Okay, exclusive or means one and only one option can be true for the output to be true. And so if you have two falses, it's not good. But if either one or the other, but not both, is true, then the result is true. But if both of them are lit up, then again it's false. Enough about that. The ones we care about are and or. We could fake having a not or a not and just by using the word not. I'll give you an example of it, but I'm not going to be able to come up with a very good one real easily. Yeah, I can. Let's go back to our code. Sick. Whoopsie. I meant to type more than this. So these are logical operators. And then there's one more. Not. Reverses the truthiness, like Colbert used to say, the truthiness. Reverses the condition. True to false, or vice versa. And triple quotes there. So if I'm going to declare two variables. Sick equals capital T, true. Tired equals capital F, false. These are called Boolean variables because they hold either true or false. Boolean vars equal true or false. In this language, you have to capitalize the first letter. Other languages, you don't. In a lot of languages, you don't type out the word and, you use two symbols. I'm going to type the symbols in and I'm going to erase them. Two ampersands mean and two vertical bars mean or in those languages. C, C++, Java. Not in this one. Guy who invented Python wanted English. Makes it the code easier to read. Alrighty, so now we're going to phrase this in such a way. We're going to phrase it one way, and then we're going to use the not operator to phrase it the other way. So if sick or tired, quote, or colon, print, parentheses, quote, stay home, end quote, in parentheses. Now we're going to use not. If not, parentheses, sick or tired, end parentheses, colon, print, go to work, end quote, end parentheses. Now really, we should have just used an else, but I'm just showing you the syntax, right? So if we are either sick or we are tired, we get to stay home. But if both of those cases are false, right, if we're not sick or we're not tired, then that evaluates to being a false, right, but then the not flips it to be a true, and so we have to go to work. That's what not means. That explanation I gave is just is more confusing than just looking at, you know, the word not in front of the thing in front of the parentheses. If you put too many nots in your expression, it becomes difficult to read, and you might want to find another way to express it. I mean, if I did this, if not grad equals quote y end quote, and not parentheses sick or not tired in parentheses, right? That breaks the brain trying to figure out what it means. I'm not going to even put it in an if statement because I can't figure out what it means. I could reword that so that it made a lot more sense. Some people don't like doing if sick. They like saying if sick equals true. Or if sick equals false rather than if not sick. So if sick is the same as if sick equals true. If not sick is the same as if sick equals false. You like that better? Go for it. Now, if sick equals true, the equals true is kind of redundant, right? Because if you deleted that, it would work just the same. But if you think it improves the readability, I'm certainly not going to count you off. A pro programmer would probably leave that off. Doesn't mean you have to, right? We're not pros yet. As soon as somebody pays you to do this, then you can decide to drop the equals true. So I'm going to rephrase this one to use that. I'm going to copy that, paste it down here, and it's going to say if sick equals true or tired equals true, then print stay home. And now I'm going to word it a different way. If sick equals false and tired equals false, colon, print go to work. End quote, in parentheses. Notice I use and rather than or to accomplish the same thing as this. I got rid of not. If you think this is easier to read than this, go for it. Pick which way you want, whichever way clicks in your brain, right? Because writing these logic statements is not absolutely intuitive, especially once you start throwing in nots. Just like the English language, you're kind of supposed to not use double negatives. People do it for style, right? I am not unhappy, but, flipping the meaning of happy, and then not meaning, the opposite of that. So it kind of means I am happy, but it could also kind of mean I'm feeling neutral, right? But double negatives, I ain't not going. Your brain has to flip a little to figure out what that means. So, the more knots you have in your logic, the more likely it is that you could rewrite it in such a way that it was clearer. If I wanted to rewrite this one so that it was clearer, I will show you how to do it. I'm not going to show you how I derive it, but I'm going to copy that. And if not grad is equal to yes, I could word it like this. If grad not equals yes, that makes it a little easier for me to read. And I could get rid of the not here if I flipped some of these things, but I'm not going to bother, right? Lots of different ways to write them. Do remember this. That means not equal. So, nah. If sick not equal to true, colon, print, you're looking well, in parentheses, end quote in parentheses, right? That's the same as if sick equals false, whichever way you think makes it easier to read. That is more than what the PowerPoint wanted at this point, but I don't care. We're smarter than the book. It means that when we hit it again, it's going to be that much easier. So if else, known as a two-way selection statement, right? You have a choice, one thing or the other. The simplest form of the if is if you have something or nothing. That's just an if statement, right? If tired, go to bed. Otherwise, we're not going to print anything at all. So you can test multiple conditions based using if, elif, elif, right? All grades above 89 are an A. All grades above 79 and 90 are a B. All grades above 69 and below 80 are C. And then everything below 70 is an F. Now, there's a hard way and an easier way to express this. So let's say that our grade is equal to 85 or something like that. Who cares what the grade is? We would ask the user. If grade greater than or equal to 90, colon, print, parentheses, quote, A, end, quote, in parentheses. If grade greater than or equal to 80, colon, this is wrong, by the way. We're going to have to make some changes to it. B, end, quote, end parentheses. If grade is greater than or equal to 70, print C, of course. And then else, colon, print F. We're kind of rude in this class. Better make a C or above. Print, you know that's not true. Print parentheses, quote, F, end quote, in parentheses. Now this logic is broken. Why is it broken? What is it going to print if I leave the logic as is? Is it going to print A? Come on, guys.
Yes.
It's not going to print A. So, thank you for answering, though. You get brownie points for answering because nobody else was. But it's not going to print A because grade is not greater than 90. So that's not a true statement. So it's not going to print A. But is it going to print B? Yeah, it's going to print B. How about C?
Yep.
Yeah, it is because it's not an else. So, bad logic. It's not going to print, or it's going to print both B and C. which is lame.
Shouldn't we make grade equal?
The way to fix it, two ways to fix it. Here's a common way people want to fix it. This table, after all, showed making it a range, right, between 79 and 90, something like that. We could do that. If grade is greater or equal to 80 and grade is less than 90, then print B.
Could you just use an elif?
Yeah, you're going to use elif. That's right. I'm going a long way to show you that you can do this wrong and you can do this right. And you can modify this one to say, and the grade is less than 80. This is totally valid logic, except for the fact that if you had a grade between 80 and 90, it would print that. It would skip that because it's not between 70 and 80, and then it would print the F. Right, so we've broken it. We would have to make this if grade less than 70. We'd have to rewrite that. So typically, if you can get away from chaining conditions like this and using else, you're a lot better off. What's another reason? What if the grade changes so that it's now 75 and above is a B, and 60 and above is a C, right? We're going to have to change several things. This is going to have to change down to 75, but then we're going to also have to remember to change that. The same number is appearing more than one place when it doesn't have to. So just like you said, else would be the way to do it. So I'm going to delete that, and I'm going to put elif there, and I'm going to put elif there. And now the logic's perfect. It behaves the way we need it to work. And I'm just going to make a parenthetical comment. If you left off elif and just did ifs, it would trigger multiple results, like printing both B and C. So when they gave that cute little table there, the table's great. If I gave you the table, great, but you might have implemented it the other way. And you can make it work the other way. There's always more than one way to do it, and sometimes one way is a lot better than the other. And I consider this a lot better than the other, and I believe the book does too, which we will see when we go to the next slide. I haven't checked to see if people have typos or whatever, and they wish that their code was working. Uno momento. Let me... And here they're showing the use of if-elifs. These are the worst PowerPoints. I need to be uploading my fixes to them. Right. Greater than 89 is an A. That's pretty cool because if you made an 89.1, then you get an A. But honestly, in this class, if you're real close, like, you know, if you're making an 89.2, I'm probably going to round it up. I try not to be a jerk. This is showing the use of or. So that should kind of be a different color to make it kind of leap out, right? If you type in a number greater than 100 or less than 0, then unless your prof allows extra credit, which sometimes I do, then the grade must be between 100 or 0, right? Either case will trigger because that's what or means. Or means that only one side has to be true for it to work. If you put an and there, it would never print that. Quite often you can reverse the truthiness of it to achieve the same thing or the opposite goal. For example, if we still have that variable called temp. If temperature is less than 32 or temperature greater than 212, we're going to just print not liquid, right? It's a gas or it's frozen. Else, colon, print, parentheses, liquid, in parentheses, end quote. But we could do it the other way. This checks to see if it's inside a range. No. If it's outside of a range, right? If it's less than 32 or greater than 212. We check to see if it's outside of a range. We could have checked to see if it was inside a range. If temperature is greater than or equal to 32, and the temperature is less than or equal to 212, then we could print it's a liquid, in parentheses, end quote, else colon, print, in parentheses, quote, not liquid, end quote, in parentheses. So in general, if you're going to check to see if something falls within a range, you're going to use and. If you're going to check to see if something falls out of a range, you're going to use or. Worth a comment. To check in a range, use and. To check out of a range, use or. Now in this case it didn't matter, really. You know, we wrote it one way, we got the same, you know, we got our output, there was no reason to rewrite it. But if we didn't need the second clause, right, if we didn't need the else at all, and then we wanted to check to see if it was outside of a range, like the example, if it's a bad grade, we want to force them to re-enter it. They typed in a grade accidentally, you know, they typed in, you made 1,000, well, you'd be happy with that. The instructor wants to know that that's a bad grade and they'd have to retype it. So that would be checking to see if it was outside of a range, right? Below 0 or greater than 100. You would use an or. I will say that you could use not and construct similar results. But I'm going to leave that behind because I'm going to use the simplest logic to express this. Here's the truth tables for and, or, and not. I've already explained truth tables. The only time and is true is when both sides are true. Or the only time it's false is if both sides are false. And then and, not just flips it, right? True but not true is false. False but not false is true. It's going to look a little strange, so I better do an explanation. The truth table for and. A false and a false. That was supposed to be 3 quotes. I just noticed because my text isn't grand. A false and a false is equal to a false. A false and a true is equal to a false. A true and a false is equal to a false. A true and a true is equal to a true. What if we replace those falses with zeros and the trues with ones? So, still for and. 0 and 0 is equal to a 0. 0 and a 1 is equal to 0. 1 and 0 is equal to 0. 1 and 1 is equal to a 1. If you look at this long enough, and if you've taken a logic course or discrete math, which probably shows this, if you have 2 F's, or you have 2 zeros and the product is a 0, and also a 0 and a 1 is a 0, and a 1 and a 0 is a 0, if you wanted to replace the word and with a multiplication symbol, it would mean the same thing, right? 0 times 0 is 0, 0 times 1 is equal to 0, 1 times 0 is equal to 0, and 1 times 1, that's the only time it's equal to 1. You could do the same thing with or, replacing it with a plus sign. I'm not going to even write the, well, I guess I better. A false and a false equals a false and a true, it's an or, so if either side is true. A true and a false, or a true or a false is true, and a true or a true is equal to a true. I'm going to do those in ones and zeros now. I could just copy and paste it, but it doesn't take that much longer to type it. A 0 or a 0 is equal to a 0. A 0 or a 1 is equal to a 1. A 1 or a 0 is equal to a 1. Now, 1 and 1, if we were doing addition, would be a 2, but it's not, because this is a world in which we only have two states, right? True and not true. So it's not going to be true. It's just going to be another one there. Right, we only have two states of electricity. It's there or not there, fundamentally at the lowest level, unless you're doing some weird quantum computing. So these could be pluses, right? 0 plus 0 is a 0. 0 plus a 1 is equal to a 1. 1 plus a 0 is equal to a 1, and so on. So OR can be thought of as addition. I'm going to go up and add a similar comment to my AND up here. And can be thought of as multiplication. So, in logic, they use that kind of notation. AB plus CD would be read as A and B or C and D. But to get it to, yeah, I don't care about that. What I do care about is knowing the order of precedence for ands and ors. Is this a good way to write it, or is this a bad way to write it? Should we use parentheses to cluster off the A's and the B's, or should we not? So if multiplication is the same as or, and addition is the same thing as or, which has higher precedence, multiplication or addition? Right. So this is higher precedence, higher priority, and this is lower precedence, lower priority. So just like if you have this phrase, 1 plus 2 times 3 plus 4, it means entirely different things if you use parentheses to cluster these things or if you don't. Because if you do it like this, 1 plus 2, that's 3, times 3 is 9, plus 4 is 13. That's actually incorrect, right? Because the rules of precedence, the order of operations is that multiplications have to be done first. Looks like a good expression, but it would not evaluate the way you wanted it to if you really wanted that to be done separate. If you did want it to be done separate, you'd put parentheses around it, right? You could do this if you wanted to force the issue. If you wanted the additions to be solved before the multiplication, you'd have to use parentheses. 1 plus 2 times, or 1 plus 2 in parentheses, times 3 plus 4 in parentheses. So if you wanted the additions first, use parens to group. Same with ands and ors. Just trust me on that rather than us write a long one. Nah, we can do it. If A or B and C or D. If you meant for this to be done first, you're in luck. You don't have to do it. But if you meant for this to be done first and this to be done first, if you wanted the ors to be done first, use parens, parentheses A or B in parentheses, and beginning parentheses C or D. Now honestly, using parentheses is not bad at all. If it makes it clearer, even if it's technically correct, nothing wrong with using parentheses. You could take this statement and you could add parentheses to it to make absolutely clear that to the person viewing the code that that gets done first. Now, we're smart enough to know that and gets done first. It's not so guaranteed that some other programmer will know that and has higher precedence than or. And then especially when you start throwing nots in. If I did this, not A or B, that probably means that I wanted that. But did I want that? Did I want the whole thing clustered? Did I only want the first thing clustered? Right? You could use parentheses to force where the not is taking effect. And even if you had it right before, the parentheses make it easier to read. So you can use parens to make it easier to read, even if the expression was already correct. Same is true of math expressions. Feel free. Use parentheses as often as you want to make it easier to read. So let's do an example where we actually ask the user for input, because that makes it more interesting, and we didn't do that. So the first thing we're going to check is to see whether something is affordable. Right. So cost is equal to float parentheses input parentheses what is the cost, end quote, end two ends of parentheses because we have two opening parentheses. And now we're going to check. If the cost is too high, if the cost is greater than $10, if cost greater than 10 colon, print parentheses quote, too expensive, in parentheses, excuse me, end quote, in parentheses. Else colon, print, okay, let's buy, end quote, in parentheses. We're going to change it up now. You have to have money in order to do that. So, money is equal to float, parentheses. Let's change that from okay, let's buy, to it's affordable. So money is equal to float, input, parentheses, quote. How much money do you have? Question mark, end quote, end parentheses. Now we're going to, I forgot to put double parentheses at the end. So if the cost is greater than 10 and our money is greater than the cost, colon, we're going to print something. Print parentheses, quote, affordable, let's buy, end quote, end parentheses. Else, excuse me, elif cost is greater than 10, and elif cost greater than 10, colon, print too expensive, end quote, in parentheses. Else, colon, print affordable but not enough money. 3 states there. Since there's 2 Boolean states here, there really ought to be 4 choices, but I'm not imagining that. So we're going to make a homework assignment based on these kind of things. First, we're going to look up where hypothermia is. Hypothermia is when you're too cold. 95 degrees is too cold in general. Some people have lower body temperatures than others. Okay, so homework. Ask the user for a body temperature in F. If it's above 99, print that they have a fever. If it's below 95, print they have hypothermia. If neither of the two are true, print no cause for alarm. That's one way. Another one. I should have just gone back and chosen the other one because my brain skipped here. Ask the user their age. Ask the user years of citizenship. If the user is less than 18 or the years of citizenship is less than or equal to 0, they can't vote. Print that they cannot vote. Otherwise, that they can. Now I'm going to make up the stupid equation here. Not true. But ask, we already have their age. So max underscore lifting, the max weight they should lift, is equal to 200 pounds minus their age. Stupid, right? But whatever. Make it 100 minus age. If age is greater than max lift, print you're hired. No. If max lift is greater than 50, print you're hired. Else print find an easier job. And lastly, if age is greater than 16 and age, we're going to look up Coast Guard ages. All right, if you're 17 years old, you need parental consent. Up to 31 years is still okay, and 32 is okay if you made an A in training. It's weird, but we're going to go for it. Age 32 and above, too old to enlist in Coast Guard. age, age 16 or below, or age 17, enlist with parents' permission. And lastly, age below 17, too young. I'm going to delete that statement because it wound up not being appropriate. And then print whether the user can join the Coast Guard based on the following information. Alrighty, that's the homework. I will tidy it up. Let's make a Dropbox. Any questions? We're not going to be I don't remember if there's a class behind us on Thursdays or not. Yes, sir.
Can you scroll back up? So I can
Yeah, absolutely. Which point? Tell me when to stop.
Just all the way at the top. I haven't even taken one yet.
Right here?
Yeah.
Okay, cool. Good to go?
Then back down.
And back down.
Bottom half.
Yeah. Yeah.
Thank you.
I'm surprised more people don't use phones to grab information. Any other questions, guys? All right, make a Dropbox and we can bail.